Let's look at the definition of the radian measure of an angle. There are two ways to measure how large an angle is. One way is by degree measure. Another way is radian measure. Recall how was 1 degree defined? How was 1 degree defined? Is defined in this way. An angle obtained by rotating the terminal side a whole circle is called the circumferential angle. Then 1/360 amount of the circumferential angle is called 1 degree. This is one way to measure how large an angle is. Okay. Now, we like to look at the animation right here to see how 1 radian was defined. Now, here is the red point, which is the center. And here is the line segment, which is the radians. So we rotate these radians counterclockwise. So it's going to give us a circle. So this will be the radians, line segment. And then we fix this point and rotate these radians based on this point. Then you see this line segment is equal to this part because, those two are the length of radians. You do more, you get here. So this line segment equals the radians. If you connect those 2 points, this line segment is also the radians. And those 3 sides are equal. So then all those angles are equal. Because the sum of 3 angles equals 180 degrees, then this angle will be 60 degrees. So this central angle is 60 degrees. This central angle is formed by 2 radians. One is this one, another is this one. So the definition of central angle is the angle that forms when 2 radii meet at the center of the circle. Okay, so this black marked angle is the central angle. Okay, let's keep playing, keep rotating. We straight this radian up. So rotate one more time. It's rotate based on this point, and then it straights up to this height. Then we start to bend these radians. Then, of course, when you bend these radians, the point will not be reach this point. You see, when you bend in this way. Okay, so then the red point is close to the black points, but they do not coincide. Okay, because the length of the arc in this case is the length of the radians. So that means when you connect the point here with the point of the center, then the angle marked by the red sector, the corresponding length of the arc is the length of the radians. So at this time, we say this central angle, red sector marked central angle, will be 1 radian angle. So 1 radian angle intuitively is smaller than 60 degrees. Because this point does not coincide with this point. So 1 radian is slightly less than 60 degrees because the bent arc length equals the radians. Okay, equals the radians. So then the corresponding central angle will be 1 radian. Okay. So 1 radian is smaller than 60 degrees. And then you will get 2 radian if this is the length of the arc here equals the radians, and the length of the arc here also equals the radians. And here you then have 1, 2, 3 parts. So 3 radians, this red sector marked angle, this angle, initial side and terminal side. So 3 radian. Okay, 1 radian is slightly less than 60 degrees. 3 radian will be slightly less than 180 degrees. So if you add 0.14 radian, that will be 3.14 radian. That's going to be pi. So pi radians is 180 degrees, a straight angle, 180 degrees. And then, this is our pi, 3.14 radians pi. That's what I said a moment ago, is 180 degrees. And then, if you rotate another semicircle, you will have a 2 pi radian. Okay, and that's 360 degrees. So 2 pi radians is 360 degrees. Okay, and then we know the area of the disk is pi r squared. We know the arc length of the whole circle is 2 pi r. The circumference is 2 pi r. So we divide the first row by 2, we will have a 180 corresponds to pi radian. That's basically on the graph is like that. Pi radian 3.14 radian is a straight angle 180 degrees, and which corresponding to the arc length pi r. So from here to here, the length of the arc is pi times r. The corresponding sect area, this semicircle is 1/2 times pi r squared. So the most important thing is pi radians is 180 degrees. That's basically right here. Pi radian is 180 degrees. And then, if each side divided by 180, you have a left-hand side is 1 degree, right-hand side is 3.14 divided by 180 is 0.01745 approximately. So 1 degree is 0.01745 radians. If both sides right here divided by pi, then the right-hand side will be 1 radian. The left-hand side is 180 divided by 3.14 divided by pi, which is 57.30 degrees, 57.30 degrees. And we know 1 radian was approximately less than 60 degrees. Exactly 1 radian is about 57.30 degrees. Okay, so how large was this one? Yeah, this red marked angle, this angle marked by the red sector is 57.30 degrees. All right. Okay, please review this lecture. I'll see you next time.